60 seconds and counting. We are go for Apollo 7 at this time. T-minus 50 seconds. The vehicle now pressurized and the vehicle is go as is the
Very good, thank you guys. We need to get started here if we're going to make time on this. So I want to introduce our first speaker to you, ladies and gentlemen. He is an internationally recognized artist who has specialized in aviation and conceptual art within the defense and aerospace industries for the better part of the last 30 years, serving the many needs of top American corporations in this regard. His father was a 25-year veteran of the United States Air Force, and as a consequence, he has had a lifelong love of aviation. Stop the feedback. We're good to go? Yeah, all right. His first UFO sighting occurred at Westover Air Force Base in the states of Massachusetts in the winter of 1966. And he observed the craft through an 80-power telescope for about 10 minutes before it accelerated out of sight at an extreme velocity. He later discovered that this craft had been hovering above a flight of nuclear-armed Boeing B-52s sitting on the alert ramp on the flight line on base. So he has spent most of his life trying to discover what kind of science would make this incredible achievement possible. And he believes that there is a plausible answer to interstellar flight without actually violating the currently accepted laws of physics. Having had literally dozens of sightings since 1966, he feels certain that this carefully protected technology has been co-opted by an as yet unknown group, and the sequestration of this technology has provided that organization tremendous leverage in world politics, in international conflicts over the past 5 decades. His website is McCandlish.com. We are also, by the way, going to show a part of the documentary a little bit later here today at 4 p.m. Called 0 Point, the Mark McCandlish story, so don't miss that one. So this is going to be a very interesting first presentation here to kind of break open this subject for us. There's so much to get to here. But he's going to speak to us about 0 Point energy, the power source behind the secret space program, and the trump card of the breakaway civilization. So with that, everyone, please help me welcome Mark McCandlish.
Good morning. Or guten Morgen. I want to talk to you about a few of the different vehicles that I believe are being used in the secret space program or have been used in the secret space program. I think we're getting some feedback here. Some of those vehicles, I never thought I had a booming voice before, but I guess I do now. Some of the vehicles include the so-called flux liner or alien reproduction vehicle. Louder, please. Okay. Let's see here. Lift this up a little bit. There we go. Is that good? Okay. Can you hear me now? Okay. This is the first generation Aurora. It was a remotely piloted vehicle. It was built by Lockheed Martin. And this object you can see in the distance was actually taken from a Polaroid photograph that was taken in 1984 near Cedarville, California, up in the northeast corner of the state. Now for me, this is the one of the other vehicles here. This is a drawing put together by my friend Michael Schratt. This particular vehicle I'll go into a little bit as well. It was a part of a crash recovery in East Germany. Now, after I got out of high school, I realized that in order to go to the... Okay, there we go. Sorry about that. One of the things I was going to need to be able to do in order to go to the college I wanted to go to, which was a place called Art Center College of Design in Pasadena, I wanted to design cars for General Motors. And this was the premier college that all the designers would go to. And at $2 an hour minimum wage at the time, I knew that there was simply no way that I could afford to save up the money to go there. So I decided to join the Air Force and get the GI Bill to help pay for my college education. And so this was the aircraft, one of several aircraft like it that I worked on when I was in the Air Force. It's the F-106 Delta Dart. So had a reputation of being one of the fastest single-engine interceptors ever built. Had an area-ruled fuselage, sort of pinched in the middle to offset the displacement of the wings. It sort of flared in the front, flared in the back, and narrow in the middle, what they call a Coke bottle design. It was something that helped to keep the stability of the aircraft intact when it would go over Mach, faster than the speed of sound. This was the squadron patch. And after I got out of the Air Force, I went to college and eventually began working in the defense industry. Spent a little time working in the special effects industry in Hollywood. And these are some of the paintings that I did. This is a cutaway illustration of a propulsion system for a lightweight torpedo that basically involves a lithium core that is ignited once it drops into the water. And that this heats up an oxidizer, flows through here, it creates steam, high temperature steam through these heat exchanging tubes here, goes through a transmission, drives a generator, and also a couple of counter-rotating props in the back. But being able to figure all that stuff out, and I take a lot of pride in the accuracy of my work, involved a certain amount of engineering. And even though I'm not an engineer, I don't have an engineering degree, I spent an awful lot of time studying how things are put together, how they work, what makes them function, what the physics and the engineering are behind these systems. You know, whether it's mapping out every single tile on the space shuttle or doing the cover of a magazine on the TR-3. This particular magazine here plays a significant role in the story that I'm about to tell you. Mapping out the plumbing for an advanced rocket system or the cover of another magazine. But eventually, while I was working in the industry, I actually had the opportunity to make contact with a lot of people in the military, some of whom expressed an interest in having some of my artwork in their squadron ready rooms. And so I was actually able to arrange to get what are called media orientation rides and go up in these planes and see how the pilots handle the stress of flying. This particular aircraft, the F-16, is capable of over 9 Gs in a turn. So this brings to mind the question, why would you want an aircraft that has that kind of capability? You know, I asked myself years and years ago, millennia ago, if man had never taken the time to study flying insects or birds or bats or any kind of a flying animal that we have on this planet, would they ever have had the inspiration to think of flying, to come up with the idea? And I kind of wonder whether or not we ever would been able to get off the ground if we hadn't had those other naturally occurring creatures to give us inspiration. And so as we begin to learn how to fly, as the Wright brothers and all the other pioneers put together these machines, it gave us this capability. Of course, there was a military application. First probably was seen during the First World War in Europe, using aircraft for observation or for bombing and harming the enemy troops. And so, as time went on, there was a competition between the different sides, looking for ways to raise the performance level of these aircraft so that you could outmaneuver your competitor, build an aircraft that could pull more Gs. This is an illustration showing that same aircraft fighting against a pair of MiG-25 Foxbats, which were an aircraft created back in the 60s by the Russians, supposedly to catch up with and chase some of our fastest high-speed, high-altitude intercontinental bombers. Now, some of the programs that I began to hear about that had to do with this enhanced performance were aircraft that utilized a newer technology referred to as stealth. Now, stealth, one of the problems that you have when you're flying into an area that's not friendly is that there are different systems that can detect your presence, whether it's radar or infrared, the heat signature of the aircraft produced by the jet engines, this kind of thing. And so the military organizations from the different countries began looking for ways to make these aircraft less apparent, less evident, ways to diffuse the exhaust signature of the aircraft, ways to reduce the radar signature of the aircraft. Excuse me. And so some of the things that they would do would be to put special exhaust diffusers on the back that also help to reduce the sound signature. Most people don't know this, but the roar that you hear from a jet engine is caused by the shearing effect when the high-speed air comes out the exhaust and cuts through the still air around the aircraft. And so by diffusing the exhaust stream, you can actually reduce the footprint of the sound made by the aircraft to make it less detectable. There are ways that you can modify the inlets for the engines so that when a radar beam from a distance is looking at the sky where the aircraft is, it's harder for that radar to get into the inlet where those metal turbine blades are turning and reflect a lot of the energy back and let the people watching for you know that you're there. And so applying these different techniques, looking for ways that you can make an aircraft perform better and do it very quietly, very stealthily, even in the materials that are used. I'm sorry, I pushed the wrong button here. These aircraft have a number of ways in which they can be deployed. They can be deployed by flying right off of runway, or they can be deployed as a parasitic aircraft, as in this case. This is the second generation Aurora on a carrier vehicle. There have been a number of questions about what the name of this vehicle was, but for me, the discovery of its reality was kind of what led me down the road to being aware, or suspicious anyway, that there was a kind of secret space program. And so the way this happened, I was approached by Lockheed Martin. I think at the time they were still referred to as only Lockheed. And the particular division that I was approached by was working or approaching me on behalf of the Skunk Works division. And they said that we have a new aircraft that we want to build, and we need to get the appropriate funds from the government. So we need you to create an illustration for us that shows an aircraft that's really fast, something that looks dynamic, very, very fast. And at the time, I was reading some of the trade journals like Aviation Week and Space Technology, and I knew that one of the up-and-coming technologies that they were talking about was something called scramjet technology, which is kind of a short term or shorthand for supersonic combustion ramjet. Basically, it's an engine that kind of starts out as a normal turbojet with turbine blades that are turning, and then you can change the flow of the air through the system so that it largely becomes just a big tube that you dump fuel into, and the air rushing into this fuel, or into this venturi, this tube, is being jammed in there so fast and at such pressure and under such heat. When air is compressed, it heats up, that this particular mechanism would cause almost a spontaneous combustion, if you will, with very little input to make the combustion process and the forward thrust to continue. And so knowing about these things and knowing kind of what the proposals were suggesting this technology would look like, I decided to put together the most interesting features from two well-known aircraft. One was the XB-70 Valkyrie from the 1960s, which was the aircraft that those MiG-25 Foxbats in that previous illustration were designed to chase. It was a high-altitude, high-speed aircraft capable of cruising in excess of Mach 2. And so I took some of the design elements from that aircraft, and I took some elements from the SR-71 Blackbird, which had kind of a chine that ran along the edges, sort of like a thin knife edge along the sides that would blend back into the main wing like this. But I thought I'd also add some canards, very similar to what the XB-70 had above and behind the cockpit. In the design that I came up with, I thought, well, there's there are times when the aircraft will not require the use of these canards up in the front. And so I designed a mechanism into the chine where it would open up like a clamshell, allow the wing to rotate into the body, and then the clamshell would close again. And I put all these features together just thinking, this is going to be a really interesting looking aircraft. They'll be really excited about this. And the reaction that I got was anything but excitement. It was actually more of a horrified anger is the best way I can describe it, because when I opened up my sketch pad and I slid it across this big, beautiful oak table to the two scientists that were sitting across from me, one of the gentlemen began to become visibly upset. Red in the face, you could practically see the beads of sweat beginning to form on his forehead. And he slammed his hand down on the drawing and said, what are these canards on the front of the aircraft here? Sorry, again, there we go, pushing the wrong button. What are the canards? What are these winglets out here? Those would be torn off at Mach 17. And then he caught himself and he realized that he'd actually disclosed the target velocity of this aircraft. And at that time, no one had any idea that there were aircraft which might have that capability. In fact, the seismologists in Southern California, at about the same time, were noting that there were these minor little earthquakes that seemed to move across Southern California in a particular direction, either going or coming from the ocean. And eventually they figured out that when you plotted the time to distance from one listening post to the next of the seismology equipment, that this was a supersonic shock wave being produced late at night by an aircraft that was moving upwards of Mach 5. And so it became evident that we had aircraft that were flying at much higher speeds than anybody believed possible. It turns out that shortly after I submitted a sketch of this particular aircraft, they decided that they were just going to completely scrap that. And so I wound up doing an illustration of an aircraft something like this. There was one proposal where it might actually be possible to deploy this particular aircraft right out of the back end of a flying C-5A Galaxy. And this is sort of my conceptualizing of how many you could actually fit into a C-5, knowing what the size of this aircraft was. It had a scramjet nacelle on the ventral surface, and it also had one on top. This particular version only had one underneath. And because of the shape of the aircraft, it made it very peculiar, or very sort of awkward where the landing gear would come out in order for this thing to work properly. Now, about the same time, there was a lot of talk about a crash, an aircraft vehicle crash that had occurred somewhere near Barstow, California. And there were some people that were describing different features of the aircraft. There was a fellow that I met and talked with who was friends with a number of the astronauts, and they were describing how there was a particular astronaut flying a Learjet, ferrying it from one location to another through the state of Nevada. And he came out of the clouds and he found himself sitting slightly above and behind an aircraft that looked just like this. Now, the interesting thing about this aircraft is that it had some very strange features. It had engines that were buried inside the fuselage with sort of an aqueduct-shaped inlet there. There was kind of a slot in the back. It looked like there was maybe a trap door, control surfaces along the bottom, exhaust diffusion. But it also had this very interesting feature, and most people don't know this, that the predecessor of the SR-71 Blackbird, the YF-12A, which was kind of a strategic aircraft used for missile delivery, it also had a folding ventral vertical stabilizer, or tail as you would call it. And so this aircraft obviously had that same particular feature. The vehicle was all black, or sort of a deep gray. And as the pilot was flying along, looking at this thing flying through the clouds, he suddenly realized that if he had not seen this thing directly, he might have collided with it as they were flying through the clouds together. So he gets on the radio to his ground control people and says, I've got some traffic up here, why didn't you warn me? And they said, well, there isn't any traffic up there. And he says, well, of course there is, I'm looking right at it. It's black, shaped like a flattened out football shape, no wings to speak of, two tails, one above, one below. And there was a slight pause in the transmission back and forth, and suddenly the pilot turns around, looks out the window, and registers an expression of surprise and anger, banks into the clouds and disappears. A short while later, the ground control intercept voice comes on, a different voice, and says, you need to divert your flight to Nellis Air Force Base, south of your position immediately. After your rollout, come to a stop at the end of the runway. You will be met at the end of the runway. Do not depart your aircraft. And so he went through a lengthy debriefing about what he saw or what he shouldn't have seen regarding this particular aircraft type. Now, one of the things that this particular aircraft had that wasn't immediately available or immediately evident was a ridge that ran laterally across the widest part of the aircraft. And on that ridge were a number of what looked like fuel ejectors or fuel injectors pointing outward. And this aircraft here was then being described within the industry as this vehicle that would produce an exhaust trail, the so-called donuts on a rope exhaust trail. That it seemed to imply that there was two different propulsion systems that were in use in the aircraft to get it up to speed. Nobody really understood what they were or what actually made the aircraft function in the way it did. But as it happened, I was asked to do this painting for Popular Science on the so-called Mach 5 spy plane, and it went into details about all the seismic events in Southern California that sort of raised the curiosity of some of the people to watch what was going on. And I remember at the time that, this is in the early 1990s, or I'm sorry, late 1980s, early 1990s, that you could go out into the high desert of Southern California at night and you could see these things flying overhead, flying back and forth. When the sun was just below the horizon, it was dark out, but there was something still up there. You could see it moving and moving very quickly. Now, about the time that I did that illustration on the magazine, I was contacted by a colleague, a friend that I went to college with, and I invited him to go to this air show at Norton Air Force Base in San Bernardino, California, which is about 75 miles east of Los Angeles. The Thunderbirds were going to fly, and it was a little bit of an overcast day, but in the end, I wasn't able to actually attend the air show, mostly because I had a job where I had to complete another illustration for a client over the weekend. Now, after that show was over with, I talked to my friend who had gone. We were going to rendezvous there. He said that he had an associate from one of the defense contractors that he wanted to introduce me to. And so I asked him how he enjoyed the air show, and he said, well, you know, I think I saw some things I wasn't supposed to see. And I said, well, how can that be possible? Anything that you have on display in the air show would be there for the public. It would be cleared ahead of time. He says, well, this wasn't exactly a public show that I went to. And I said, well, what are you talking about? Well, it turns out over the next few years, I began to get the details of what had happened. But right about the time the Thunderbirds flying demonstration team was beginning to do their exhibit, the gentleman that my friend was with said, let's go over here. So they go into a hangar, and there's a group of other people there, including some well-known congressmen. Senator Alan Cranston was allegedly there. Congressman George E. Brown, who was the chairman of the Congressional Committee on Space Science and Advanced Technology, was there. And a lot of high-ranking military brass. They all boarded a military passenger jet, a 727, and were flown up to Palmdale, to Air Force Plant 42, where you find Lockheed Skunk Works located. This is the building that was actually used for the construction of the L-1011 airliner when it was in production, and is now the home of the Skunk Works. Now, here's another angle on the same building. You can see how massive these hangar doors are. Now, as they were going into the hangar, the gentleman turns to my friend and says, he just realized that there are some aircraft on exhibit here that you're not cleared for, to security-wise. You are not cleared to see these aircraft. So just enjoy the show, walk around, listen, take a look, but don't say anything to anybody. So he goes in. I don't know how well you can see this because it came out kind of light, but there were two pieces, or two sections to this particular hangar on the inside. On the southern side, which would be over here, they had a number of aircraft, including the first generation Aurora, which I'll go into a little bit more here in a bit. They had the F-117A stealth fighter. They had the losing competitor in the B-2 advanced technology bomber competition, which led to the creation of the flying wing Northrop B-2 bomber, the Spirit. Also had a couple of odd little hovercraft. I'm sorry, right here. This particular vehicle here, this is kind of a close-up, a rough close-up. It was a sort of an answer to or a follow-up to the A-10 Warthog, which was an anti-armor aircraft. It's a vehicle that carries a very big Gatling gun, fires thousands of rounds per minute, and has a very durable, very hard aircraft to take out of the sky. It's very well, or very heavily armored. Has a big gun that sits inside of it. And so this aircraft here was designed with a very unusual kind of a wing. Now, in aerodynamics, they have something called the Coanda effect. And basically, it involves blowing air across the surface of a wing to provide lift rather than just relying on the movement of the wing going through the air in order to provide that same lift. So what they did, the design of this aircraft was that they came up with a way for mounting the engines above and slightly ahead of the wing, and then they took these high-temperature alloy, it's like a flattened-out funnel shape, really, that blows right over the wing. And when the wings are all rotated in sequence, it forms a nice smooth ramp that the air can actually flow down. It goes from horizontal, following the surface of the wing with this Coanda effect, kind of a aerodynamic adhesion in a way. And so it redirects the thrust of the engine to a point where it's pointing almost straight down, right about where the center of gravity is for the aircraft. Now here's a computer-generated image that shows a little bit more detail of the same vehicle. The hovercraft were kind of unusual. There was one that had a jet engine that was in the tail of it, kind of a teardrop shape, and then around the perimeter it had a series of little trap doors that would open and close as the thing was flying along. And this jet engine also had a transmission that connected up to a set of counter-rotating turbine blades that surrounded what amounted to a bubble-type cockpit, almost like something you'd expect George Jetson to be flying in one of his little cartoons. This one over here, I've actually seen a version that's very similar to this in one of the popular science magazines, where it had a turbine in the front and two in the back, one on either side, that were driven by this particular engine here through a transmission of kind. And it had the same sort of sphere-shaped cockpit too. Now, Senior Peg was the code name that they gave to the development of the advanced technology bomber, and this was Lockheed's version here. And you can see it is kind of a derivation of the F-117A. It has the same kind of faceted surfaces, which help to reduce the radar cross-section or the amount of radar that's reflected back to an antenna from a source inside enemy territory. Had the flush inlets on either side of the cockpit with a screen over them to prevent the turbine blades from reflecting a lot of energy back out to a signal source. But this here was one of the more interesting vehicles, and you can see some of the stats on it down below. This was probably one of the largest unmanned weapon systems built to that time. And this, from my different sources in the military, this aircraft, which was known as the first generation Aurora, nicknamed the Pulsar, was entirely covered with space shuttle tiles. You can see evidence of the tiles all around the surface of the aircraft. And just like the aircraft that I showed you earlier that had the tail above and below the fuselage, this aircraft had the NACA duct-style inlets for 4 engines and 4 exhausts, and this is both on the top and on the ventral surface, or the belly of the aircraft. In fact, after I had discussed this particular weapon system on coast to coast with one of the hosts that was working that particular program, I received some email from a number of sources indicating that there were inlets and exhaust ports both on the top surface and on the ventral surface. Now, at the time of the exhibit, my friend said that he could only see the underside of the aircraft. He couldn't see the top of it because it sat up kind of high off the ground. And so he didn't know whether there were 8 exhaust ports or only 4. And it turned out that one of the people that I corresponded with after doing the radio program said that they had been jogging late at night during an evening when there was an aircraft like this that was leaving one of the United States Air Force bases in Great Britain. And he said that what was unusual about the aircraft is that when it went to take off and it lit up the afterburners, which dumps a lot of extra fuel into the exhaust stream, and you see this sort of a bluish glow coming out of the exhaust. He said there were 8 ports, which of course helps to point out that you have 4 above and 4 below. So we knew that was true. One of the things that was interesting about this aircraft was that it had that same system of these exhaust, or I should say fuel ejectors on not only the top surface right along this ridge, but also on the ventral surface on the underside as well. So here we have 2 different propulsion systems incorporated into one aircraft. And there was a third propulsion system that was back here in the back end. It had a pair of sort of trapdoors, clamshell arrangement that would open up and expose an exhaust port. And there were a pair of little pods that would sort of rotate out into position that had maneuvering jets so that this aircraft, once it got up to a certain altitude, could go into a shallow dive, pull up, and go completely exo-atmospheric, go right out of the atmosphere into space. And once it did, then of course it could continue onward using a rocket engine, which of course provides its own oxygen and fuel. Since you're outside the atmosphere, you don't have any air you can breathe or use in the combustion reaction. And so one of the things that helped illustrate that this aircraft was not only being used, but probably in deployment, was the fact that all along the trailing edge of this aircraft, in this area here, these heat ablative tiles that were on the tail end of this aircraft were all highly eroded from the pressure and the temperatures of the exhaust and the fuel that's being burned. Now, they say that it might have been slush hydrogen, it might have been liquid methane. I don't really know for sure. But the one thing that's also notable is that it had a synthetic vision system up in the front. It had a pair of infrared cameras. And these 2 cameras that would actually allow a pilot sitting on the ground, and I've been told that this remotely piloted station was at Indian Springs Air Force Base near Las Vegas, Nevada. But the pilot could sit at the controls of the aircraft as though he was actually in the aircraft. And he would wear a special helmet that would have a kind of heads-up display in it that would give him a left eye and a right eye view of what the surrounding terrain was. And it was all in infrared. So this would permit him the opportunity to see where he was going, even to take off and to land the aircraft without actually being in the aircraft itself. Now, one of the things that you don't see in this particular illustration, but is a little bit more evident in this illustration that I did for Aviation Week, the perspective on the underside is a little bit off. These should be flattened out more, but there's 121 vertical launch tubes in the belly of this vehicle. And each one of them is capable of carrying something like a cone-shaped reentry vehicle, like a MIRV, which also suggests, deployment from outer space. The way the system would work was remarkably simple. It had a kind of tile with explosive bolts holding it in place on the outer skin, and sitting up behind it, the weapon would be held in place. And it's not shown in this thing, but I've subsequently learned that there was kind of a 3-piece fiberglass sabot which would hold the weapon straight in the bore, so it would always be pointing a certain direction. But the ingenious and simple aspect of this thing was that when the explosive bolts on the outside were ignited, the tile would disintegrate and blow away. And when it did, there was a big coiled spring about 12 inches in diameter behind the vehicle that would push it out of the hole. And right behind the reentry vehicle was another tile that would slam down into place and cover up that hole again, almost like in a tenth of a second. The reentry vehicle, oh geez, sorry. The reentry vehicle, let's see, where are we? Right there, would then stabilize, because of its center of gravity weights and the shape of it, would stabilize in the airstream, go into the atmosphere, and be able to acquire its target and do its job. Now, further verification of the existence of this aircraft came from Jane's Defense Weekly, part of their intelligence briefing newspaper. And this was apparently an artist's rendition of what the same kind of aircraft, if it had been built by McDonnell Douglas, would have looked like. And so you can see that there's the same sort of ridge running laterally across the flattened football shape, exhaust coming out the back, and some other ports that suggest there's an internal system of engines as well. So it reflects the same sort of design philosophy, even though the manufacturer was different. One of the things that this particular aircraft would do, if you look at the ridge here where these fuel ejectors were located, would expel the fuel, and the fuel would be ignited by just the intense pressure and heat of the air flowing across the front of the aircraft. Now, one of the things the artist did not capture in this particular view was the fact that the front end of this thing is going through the air so fast that it's glowing red hot, just because of the speed through the velocity, the friction going through the air at such a high speed. And so as that air is further compressed as it comes up on this ridge right here, and then it meets with the fuel. As the fuel is sprayed into the airstream, it spontaneously combusts. But by this time, the aircraft is already going well above Mach, over Mach 1. So there's a supersonic shock wave that forms and basically separates, doggone it. Got to watch those buttons. The airflow separates right at that ridge and then causes the fuel to explode, and the fuel explodes between the tapered afterbody of the vehicle, which is what causes the erosion, and the shock wave of the supersonic shock wave coming off the aircraft. Now, let's see here. Shortly after my friend and his escort entered into the show, they were brought into an area where there were 3 flying saucers hovering off the floor, no landing gear underneath, basically just floating. And there was the smallest of the 3 vehicles. It had a rolling staircase in front of it. You could climb up, you could look inside, see the components. They had a videotape playing on a TV next to it that showed one actually flying around and doing various things. They had a podium with a 3-star general that got up and described the capabilities of this vehicle, and 2 other larger versions of it that were behind it, much larger. You can tell by the size of the door going inside. The synthetic vision system, which involved a number of cameras on the outside. This is the 60-foot version here. This one here was somewhere between 150 and 120 feet in diameter at the bottom, right down there. So one of the things that tells you is that whatever the technology is that's running this thing, whatever makes it work, is scalable. That is to say, you can make a little one or a big one, but without too many different adjustments in the technology, you can actually make this thing work the same way on a small scale as it will on a large scale. Now, ultimately, I wound up producing a cutaway illustration that was based on what the eyewitness told me about what he'd seen. And he was very specific. I mean, this is a young man who's an outstanding designer. He has the ability to kind of look at things and remember what he's seen, almost like a photographic memory. And so he was able to rattle off the dimensions of all the different components in the system. He described a capacitor array in the bottom that had stacks of 8 individual copper-colored plates, and they had a series that went all the way around this vehicle, that there were so many inches wide, something like 12 to 14 inches wide at the outer edge, that they were embedded in a kind of a glass-like substance, maybe a quartz or some kind of a high dielectric resin of some kind. There was a little robotic arm that could extend out through doors that would open on the side. There were oxygen tanks. But the thing that was really interesting about the vehicle was that everything on the vehicle was made of synthetic material. There was really very little metal used in the construction of this vehicle. The sides were made of a composite material, something like carbon or Kevlar. The entire crew compartment was a big sphere. And this sphere was what you would call a pultruded component. Pultrusion is a process where you take a shape, in this case, a sphere. I must have hit that button again, huh? There we go. Here's a little bit better diagram. You can actually see a little bit of the texture. This was a computer-generated illustration. It was done by my friend, the late James Allen, who also produced the film about some of the research I did into this. And the pultrusion process is one in which you have a kind of a mandrel, a shape that you want to turn into a composite vessel for storing high-pressure gases or being allowed to an object that'll go into an environment where there's a lot of high pressure. And so what they do is they have a strand of or a number of strands of these composite materials, and the strand is wrapped around this mandrel as it's being tilted and rotated on like a spindle. And it's impregnated with resin as the fibers are being wrapped around it so that they all stick to one another. It's pulled tightly, pultrusion. And so in the end, you have a structure that is extremely strong. And in fact, the little oxygen tanks that are down here in the bottom were also pultruded vessels, and you can find images of those just about anywhere online. And each one of them was about 12 to 14 inches in diameter and about 6 feet long. So the witness estimated that the crew compartment right here, this section that's up at the top, is the upper half of that sphere. The sphere actually goes down below and is joined by a kind of a fillet down here with the top of this capacitor array. After I took the different dimensions that he had given me, I was able to plot out the exact number of capacitor sections that comprised this array at the bottom, and there's 48. Now, that number was very significant because shortly after this particular information came to me, the Los Angeles Times newspaper was running a story about crop circles. And there was a lot of debate about whether it was something that was being hoaxed or whether it was some kind of a natural phenomenon, highly ionized winds blowing over the hillsides in Great Britain, this kind of thing. But some researcher went back a year later to see what would happen when the new crop grew up out of that same soil. And they discovered that when these crop circles grew back, they grew back with a perfectly symmetrical pattern having 48 spokes, the exact same number of capacitor sections in this particular propulsion system. So I began looking at, how would you produce a crop circle using a propulsion system like this? Well, we know that the system has a series of coils around the crew compartment here. There's another series of coils that go up in this central column. So this layout has a configuration that looks very much like a Tesla coil, which is really just a high voltage transformer. You take a certain amount of voltage, you put it in, the two coils reach a kind of resonance, and in the process, it steps up the voltage to a much higher level, millions of volts in the case of something this size here. And so when you put all of that electricity into a capacitor array down here, where you have all these plates that have positive and negative charges, you can build up a tremendous amount of voltage. Now, the first thing I thought of when I saw this was that this must have some bearing on a phenomenon that was discovered by Alfred Beefield and Thomas Townsend Brown back in the 1930s or 1940s called the Beefield-Brown effect. And really all it amounted to was putting a lot of voltage on a set of parallel plate capacitors. And in most instances, they were talking about asymmetrical capacitors where the plate that was positively charged was smaller in size, and then the larger plate was negatively charged, and that there seemed to be this kind of levitating effect where one would literally sort of by like lifting yourself up by your bootstraps, would basically hover to a certain point and then kind of pin itself to a location in the air. Now, I began talking about some of the information that had come to me with some of my colleagues in the aerospace industry, one of whom had actually worked with a young man, I think it was the University of Arizona in Tucson, who was studying metallurgy. So it turns out material science really starts to play a significant role in how these different things are created, how they perform. And what he described was his roommate from college had been experimenting with a number of parallel plate capacitors, putting a sheet of glass in between, sandwiching this arrangement, putting a positive charge on the one plate, a negative charge on the other, and the thing would actually levitate. And so shortly after this particular revelation was made on campus, the campus was visited by a number of men in three-piece suits who called everyone together who'd seen anything having to do with this experiment and said, basically, this is something that you will not talk about, it's classified. And that is surprising considering that there's so much literature that was already out I remember hearing in the late 70s, early 1980s about these lifters that you could build, with foil and a spark coil from a car and this kind of thing. And so as I began looking at the components and sort of sifting through the details of what this individual had told me, I began to realize that there had to be some significance to the material science that was involved. Now, for any of you who followed Coast to Coast AM, where I was a guest a number of times with Art Bell and with George Norrie, there was a story about a young man whose grandfather had actually visited the crash site of an alleged UFO in Roswell, New Mexico in 1947. And that this young man had actually pocketed a number of pieces of this metal that he'd found on the ground. And that when they took some of this metal and they sliced through it and they looked under a scanning electron microscope, that they found it to be a foil laminate, a foil lamination, and that the layers of foil were comprised of a layer of a magnesium zinc alloy, and in between was a layer of bismuth. Now it turns out that bismuth is one of the components in solder. It's a metal that melts at a low temperature so you can connect electrical wires in an electrical system. They use it in all kinds of electronics, but its advantage is that it melts at a low temperature. So when you look at this scanning electron microscope and it shows the different layers in the so-called ARTS parts, you see the stratified layers of the magnesium zinc foil with this dark layer of bismuth in between, and you can actually see some heat discoloration that radiates out from each one of the layers where the bismuth is, which suggests that it was used not only as a binding agent, but it was used for some other purpose. You could see the discoloration in the other material. So I began looking around in the defense industry for companies that would produce different kinds of alloys and to find out whether you could get those alloys in something like a foil. And it turned out that the Dow Chemical Company produced magnesium zinc foil that you could buy. And you could buy it down to certain fine thicknesses, something around 1 mil or 2 mils thick, about the thickness of one of those plastic tarps that you lay out when you're going to paint the house or something. And they called this alloy AZ31X. And it was fairly expensive. I think a 25-foot long roll, 1 foot wide, was about $250. So I began to realize that there was actually a way that you could build this. And so the next step was to try and figure out how these capacitor plates that are down here in the bottom, how they were put together. And on top of everything else, embedded in a kind of a glass-like substance. I didn't realize at the time that the substance that they were buried in has some significance as well, but I'll get to that in a little bit. But the witness said that these plates looked like they were just made of copper. And so I thought that didn't seem quite right. But it occurred to me that magnesium is a metal that's flammable. It's one of the metals that you use in roadside flares, where you light it and it glows kind of a reddish color. You see them along the highway during accidents and things like that. And so if you're going to be melting down some quartz or some kind of glass-like substance and pouring it around these plates to not only form the dielectric, but to be a kind of an insulator, especially if you've got high voltage potential between these different plates. You don't want it to short out, especially if you're at thousands and thousands of feet above the ground. So it occurred to me that you would want to take this magnesium zinc alloy, this foil laminate, and you would want to clad it, to wrap it in a kind of a copper foil and seal it in such a way so that when you put this material into a mold and poured this molten glass-like substance around these individual plates, that it wouldn't cook off the magnesium. You wouldn't ignite the magnesium and cause an explosion or something. And so I looked at different ways that it would be possible to do that, things that are commonly known in the defense industry. One is that you basically create a mold that is in an oxygen-free environment. You backfill the space with an inert gas like nitrogen or argon so that there's no ignition that can occur, even if the temperature is high enough to set off the magnesium. So the other thing about that, of course, is that all of these components here are radially oriented. It's a little bit easier to see in this drawing here, but you can see that they all radiate out from a common center point. So if you think about it, there's a process that is used throughout the industry, even in the dental industry, called centrifugal casting. Now, what you do in centrifugal casting is that you create the mold and whatever components you want to go in that mold. You have a kind of a sprue that's in the middle, and then you take the molten component that you want to go into the mold and you pour it into the center of the mold through a kind of a sprue, kind of like a funnel-shaped opening. And if the mold is spinning, the molten material flows out to the outer edges and it pushes away all the little air bubbles that might get trapped, and they all migrate back to the center where they can be drawn out, and so you wind up with a system. You wind up with a single casting, if you will, with all of these components in it that will not have any air bubbles, will not have any occlusions or impurities, anything that would cause the system to short out when you're using millions and millions of volts of electricity. But even so, when I sat down and I computed what the total weight of all that metal and all that quartz would be, 24 inches or 24 feet in diameter and 12 to 14 inches thick, it worked out to something like 24,000 pounds. So you have to say to yourself, how can something that weighs 24,000 pounds get off the ground? Especially if nobody believes anyway that something using the Biefeld-Brown effect could actually levitate that would weigh that much. And one of the things that the witness said was that the greater the mass of the dielectric, if you dope it with other materials like uranium or something of that nature, that you can actually increase, you can enhance the effect. So here again, material science comes into play. It becomes very, very important in how things happen. One of the things that has been talked about very often is sort of the universal speed limit, the speed of light. How it's impossible to travel faster than the speed of light, and yet experiments have been done in recent times. Sort of an anti-gravity experiment that was done by a Russian fellow, Yevgeny Podkletnov, where they had a spinning disk made of a superconducting material with coils around it, very similar to what you see here. And they found that when this superconducting disk was chilled down to its particular operational temperature, that there was a kind of beam of an environment above this disk where objects sitting in that environment had approximately 3% less mass than under normal circumstances. So you could actually reduce the mass of the vehicle by using this kind of technology. Now, one of the things that I've noticed over time in the industry is that there are different kinds of technologies that are combined. For example, when the jet engine first started coming into use, there were aircraft that were actually built that had propellers on the front of them, but it had jet engines, the very basic, the very earliest rudimentary versions of turbine jet engines that were not very reliable, were also sort of embedded in the body of the aircraft. So you had both the well-known and the reliable propeller-driven aircraft, and then you had a jet engine that you could fire up to see if you could get it going faster. And so you see times in history, in the production of different kinds of aircraft, where they combine different ideas to try and enhance the abilities of one. Now, earlier when I talked to you about what you would want to do, why you would want to build an aircraft that handles better or pulls more Gs than another aircraft, like the F-16 that can pull over 9 Gs. Well, imagine if you had a vehicle that was capable all by itself of pulling over 9 Gs, but then you put a device like this in the tail end of it that basically created an environment, the same environment inhabited by the aircraft, that had, I don't know, 3% less mass, 4% less mass. That means that when the aircraft goes into a turn, its inertia is reduced, and it means that there will not be as much stress placed on the aircraft if you pull maybe 9.5 Gs, maybe 10 Gs. And that 10 Gs gives you an advantage aerodynamically over any opponent that might be flying against you in a dogfight, like in the movie Top Gun, where they're trying to get into a firing position behind the other guy, and the other guy is trying to get away and get behind him, this kind of thing. Well, after doing some of these interviews on the radio, there were 2 witnesses, 2 people who called me or got a hold of me through the internet that I talked to, that said that they'd actually seen this set of circumstances that I just described for you what would appear to be normal jet aircraft with no jet noise, hovering, floating around in the sky. In one instance, there was a gentleman who was up very early in the morning. He was out jogging with the dog. He decided to jog up this hillside near the town where he lived, when there was the big water tower that supplied the water for the town up on the top of the hill. And it was in kind of a forest area, so it wasn't really immediately apparent that this big tower was there. And so as he's jogging up the hill, he comes into the clearing where the water tower is, and he sees this aircraft, a normal-looking jet aircraft, floating around, orbiting this water tower as he comes out in the clearing, just going around it very quietly. And the pilot's sort of looking around, making sure that he's not bumping into anything, and he looks down and sees the jogger, lights up the engine and takes off, like a normal aircraft. So it showed that at least in some way, and there was another eyewitness who had also seen something very similar to that. So it shows how you can combine technologies, maybe even surreptitiously, in a way that allows you to enhance the performance of an existing system. Now, there's been a lot of discussion about the B-2 stealth bomber having the same capability, that there are eyewitnesses who say they've actually seen the stealth bomber, rather than rolling down a runway and taking off using the lift of its wings in the normal fashion, that they've actually seen it just quietly lift right off the tarmac and fly away. So it's obvious that some of this technology is beginning to receive some application within the industry, within the different aircraft types. Now, this is a little bit easier way for you to be able to see some of the basic components on the inside. This is also done by James Allen. There's a central column that goes down through the middle. Now, the central column was referred to as the amplifier section. It had a chamber inside, and in this particular vehicle was filled with a kind of mercury vapor. And the primary windings of the Tesla coil were right here. This is, it's not exactly to scale here, but it's probably about 18 inches about 18 inches wide at the top, about 9 inches thick, and about 2 inches wide at the bottom. Or I'm sorry, 2 feet wide at the bottom. The interesting thing about this is that these coils were also embedded in this glass-like substance. Now, after I became one of the witnesses in the Disclosure Project around 2000, 2001, Dr. Greer put me in contact with a witness who said that his mom had actually worked on this vehicle at Lockheed Skunk Works. And he identified the material that these capacitor plates and the coils are embedded inside of. And he said it was something called Herkimer quartz diamond. Now, Herkimer quartz diamond is mined only in a few places in the world. One of them, it gets its name from the little town where the mine is located, near Herkimer, New York, I believe it is. And this particular kind of rock material, this quartz, is significant in that when the crystals form in the ground, they're almost perfectly optically clear. They usually show up in the form of double terminated, I mean, like the kind of jewelry and things that you would see in a New Age shop, you know, that have these mystical powers that are attributed to them and this kind of thing. But he said that what they would do is they would melt this quartz down, they'd make sure that it didn't have any impurities, they'd clear it all out, get all the air bubbles out, and they would cast the coils, oh, sorry. Boy, oh boy, am I getting off track here. There we go, okay. It would cast the coils in this material. Now, one of the things that the witness had said to me about these coils, that there were some specific dimensional features that seemed to find sort of a common application throughout the entire design of the vehicle. For example, the plates, the capacitor plates down here, were 1/2 an inch thick, but they were separated by 3/4 of an inch, about 150% more material, by 3/4 of an inch of this Herkimer quartz diamond material in between. The plates were also set up in such a way that let me go to the next one here. You can see a little bit easier here. The plates in each stack were staggered in such a way that the gaps on one lined up with the plates on the other. Now there's a significance there because if you map this out on a piece of paper, you see very clearly that if you had something, you know, 1/16 of an inch thick, you could slide it in between so that with the gap that's between this thing here, if you say had a laser beam like this thing I'm carrying right here in my hand, and you shined it through this material, that it would be able to filter through all the gaps because of the way that these plates are aligned. And so I began to look at other things that might be happening, other phenomenon. It also occurred to me that what was really strange about the coils is that normally, if you're going to be talking about an electrical circuit that uses millions of volts of electricity, that you want to use wire that has many strands that are twisted together so it can conduct more current. Now, part of the reason for that is that if you know anything about physics, you know that electrons are all negatively charged. And you can't really bring them together, except in the instance of superconductors, but you can't really bring them together because a like charge repel. And so when you have a conductor and the electrons are basically jumping from one atom to the next as the pulse of electricity is flowing through the conducting material, the electrons tend to repel one another, so they all migrate out to the surface of the conductor. So if you have, as in this instance here, you have coils, single filament copper wire, or at least what appears to be a single filament copper wire, running through this quartz-like material without multiple strands to conduct more electricity, it just seems like a contradiction. And so I began wondering if, in fact, this wasn't just copper wire, it was copper tubing, and that there was something else on the inside of the copper tubing. So then I looked at some of the notes from the eyewitness, and he described on the inside of this central column that wrapping around the inside of that tube, and I thought of this as like a high voltage, sort of like a cyclotron or some kind of a device that produced high voltage. In fact, I think that what was really happening was that the electricity would jump between these 2 points and it would create a high voltage event. Now it turns out that there was a friend of mine, a physicist, who went to Edwards Air Force Base and was given a tour, and he was actually shown what is called a free energy device or an over unity device. And this was the electrical circuit design for that device. And it amounts to a kind of a glass tube, has an anode or an anode down here and a cathode. You have a high voltage source. You have a takeoff point for your oscilloscope. You have a variable resistor and so forth. And then you have a coil that's in the circuit itself, that's resonant with the circuit, that wraps around the outside of it. And then you have a sheath that is grounded over here. That's what that symbol means right there. So This device that this friend of mine saw was supposedly putting out 125% more power than you would actually put into it. And this is what you call an over-unity device. Now, free energy is kind of a misused term. I mean, technically speaking, the gravity, if I were to drop this, I know for a fact that it's going to drop to the ground. And that potential, that energy of it dropping can be used. That's what's used in hydroelectric dam, is the potential of the water sitting up high, flowing downhill through a turbine blade, creating electricity, generators, and that kind of thing. So solar energy, the energy from the sun coming down and hitting a photovoltaic array, that's a kind of free energy too. They're not trying to kill people for creating it, but the minute you create a device that produces more energy than you put into it, then people start to get really worried, because it means that if you're not real careful about how you apply the technology, that you can actually get into what is called a feedback loop, or like the sound that we've had problems with, where the sound that's in the environment that's produced by the system feeds back through the microphone and begins to enhance, and it multiplies upon itself, and it snowballs to a point where you get an unpleasant result. And now in the case of energy, the big worry is that you're going to produce a device that produces so much energy that you can't get close enough to turn it off. It'll kill you. Or that you will have a runaway condition where it creates something like a nuclear explosion. And so I began looking around for some evidence that this device that was described actually exists. And it turns out, if you look down the bottom of that page, you'll see pretty much exactly what he described. This is a patent. This was patented by a gentleman named Kenneth Shoulders. He was a fellow who worked with another friend of mine, Hal Puthoff, for a number of years. And he had done a lot of research into something called zero-point energy. Zero-point energy, is a technical term in the physics literature, is quantum zero-point fluctuations of the vacuum. Now, the discovery of zero-point energy was made probably back around the end of the 1800s, early 1900s. They were beginning to experiment with cryogenic fluids, taking a gas like nitrogen or oxygen and compressing it down to the point where it actually became a liquid, became super cold, hundreds of degrees below zero. And the research they were doing was trying to find out what the actual temperature was of absolute zero. And by absolute zero, I mean that there's no warmth left in the material. There's no Brownian motion. There's no movement where the individual atoms or molecules are vibrating, bouncing around. And they found that even when they got down to the point of almost absolute zero, there was still this kind of vibration in the material. The German physicist Max Planck called it Zitterbewegung, which means jiggle. And so they determined that this jiggle was a kind of electrical charge that was embedded in the fabric of space-time, and that's where the name comes from, zero-point energy, looking for zero energy. 15 minutes, okay, thank you. So I started looking at what zero-point energy is, where it comes from, how it can be manipulated. And I looked at some of the papers that were written by scientists like Bernard Hayes, Alfonso Rueda, Hal Puthoff, Daniel Cole. And in the early 1990s, they wrote a number of papers that actually described, and you can see the similarity between the two things. You can see that there's clearly a design similarity. And yet, I look for other possibilities as well. The possibility that we had something like an anti-proton trap going on here, where there might be some aspect, you have the same kind of coils going around the outside, a central column, a way of trapping antimatter. I thought that this might be something like the so-called antimatter drive that was used in some of the Star Trek vehicles. So I began conceptualizing, began looking at different ways that you could actually make this system work. Now, somewhere along, I think it was somewhere in the late 1990s, early 2000s, I came across a number of books that described, Joseph P. Farrell, who's another one of the speakers here, had found some historical records after the Second World War that described a device that was being worked on by the Nazis in the Wenceslas mine up in southern Poland, called the Nazi Bell Project, or Die Glocke. Now, that particular system, based on the documents that were found, was made up of a pair of counter-rotating cylinders, one inside the other, with a coil that went around the outside. And electricity was being fired through the system. So I started looking at ways that you can make that work. Now, the first thing I thought of was that if you put a lot of electricity in this thing and you have big coils around it, that you actually may wind up in a situation where you can't get an electrical motor to actually drive the system unless you had a pulley system that was sitting way off to the side away from the electromagnetic fields that would sort of interfere with its operation. But I found out that, of course, Mercury has some interesting characteristics. I think there's something referred to as the nuclear spin ratio. The particles in the nucleus of the atom of Mercury and the electron shells, there's a spin ratio of something like 60 to 2. And bismuth, by the way, also has the same kind of property. And so I thought it was interesting that these two materials had these unusual characteristics that might make them very important in the operation of this kind of thing. So but what I found was that it goes all the way back to Michael Faraday, and the first electrical motor was really just a puddle of mercury with a magnet, a permanent magnet sitting in the middle of it in a petri dish. And he had a little scaffold off to one side with a copper conductor, and he put one wire into the mercury, send it over to the battery. Another wire would hang down from the top of this little scaffold. And the minute you connected the circuit, the mercury would begin circulating around inside the petri dish, around this magnetic field. And so if you look at the way the field lines are set up in this particular vehicle here, you can see that the field lines basically will go out around the outside and stroke down through the middle. That's what they do. And so by setting the system up in the way that it has been, you already have the built-in mechanism to make this thing rotate on the inside, just like Michael Faraday's little motor from back in the 1890s, I think it was. But the other thing that I realized was that you're going to have some way of circulating the mercury. And so in one of the instances that I was looking at ways to mechanically do this and to get this counter-rotation thing going on that was described in some of the papers from the Nazis' experiment, was creating a kind of a planetary gear drive system that would sit either at the top or the bottom, so that as one of the cylinders is turning in one way, the gears would actually force the other cylinder to turn in the opposite direction. And the benefit of doing something like this is that when you have things turning in opposite directions or sliding across one another, you get this vorticular motion in the mercury. And it seemed to me that that particular vorticular motion was something that would be very significant, very important to the operation of the system. And it's all leading up to the tapping of zero-point energy, which I'm going to get into here shortly. But the idea was that the mercury would come up in the gap between the two cylinders, it would reach the top, and it would be basically forced down through this venturi, this little funnel-shaped opening in the bottom. You'd have your cathode up here at the top, and you'd have a ring embedded in the quartz of the interior cylinder. This is the other cylinder on the inside here. And you'd have coils inside so that as the mercury was being charged with electricity, it would actually cause the mercury to be circulating. But because the cylinders are turning in opposite directions, you get this natural sort of tornado-like vortex formation in the movement of the mercury through the system. Now, the next thing that I did, it's not as easy to see in this particular diagram. I think maybe, I wonder if the next diagram has, here's a little bit better way to see it right here, down here in the corner. You see the mercury comes up here, and it goes down through this opening, and then right below that second electrode that's shaped like a ring right there, you get the electricity jumping from there to there as the mercury is being pumped through by the natural flow caused by the electricity that's going through it. As a sudden discharge of electricity goes through the mercury, and the mercury is spinning it the whole time. It's spinning like a tornado. You send the electricity through it, and when you do, it creates a phenomenon that's very similar to when a smoker blows a smoke ring. And if you've ever studied a smoke ring, you can see that it's caused by a sudden discharge of the smoke from the lips of the smoker, and the surrounding still air slows down the outer edge of the smoke as it's being expelled. So it creates a self-stabilizing event where the smoke forms a perfect ring. Even dolphins can do this with the air that's blown out of their blowhole. Now, the other thing about that is that you find that as this phenomenon is moving downward, probably something approaching supersonic speeds, down through this central column here. There we go, down through the center, right there. That because of the rotation of the device, that not only is it creating a kind of a smoke ring of ions, highly charged ions that are blowing down through the center of this device, but you also have a precessing, a rotating around a horizontal axis and a vertical axis, so that you have this twisting motion that goes on. And so what that actually winds up simulating, what it winds up simulating is ball lightning, which is a naturally occurring phenomenon. It's noted for its ability to sort of be self-sustaining. It creates its own electromagnetic field. So in the process, what I really think that I've sort of stumbled across is a way in which this system here has three different electromagnetic fields. It has the one created by the primary windings of the Tesla coil. It has the windings in the center that also creates their electromagnetic field. But then when that plasma ring, or I should say is actually a sort of a low temperature plasma-like phenomenon, or a virtual plasma, it fires down through the center, and it also creates its own set of electromagnetic field lines. And so what happens is you have an effect that's very similar to, you've heard of the electromagnetic pulse that occurs when a nuclear bomb goes off. Well, they actually have a weapon. It's called the explosively pumped electromagnetic pulse weapon. And it does the same thing. And what it does, it just combines overlapping electromagnetic field lines, and then using explosives, it pinches all those magnetic field lines, and it creates a powerful pulse. And so what I'm suggesting to you is that process actually forms a kind of a doorway for tapping into this zero-point energy. Now, why is that significant? Why does that mean anything? Well, part of the reason is that this device, when it taps into zero-point energy, they've shown that zero-point energy is actually responsible for the effect of gravity, for inertia, and for mass. And so if you're pulling some of that energy out of the environment, it may be, even though there's an infinite amount, I mean, some of the latest figures are 10 to the 109th power joules per cubic centimeter. That's one of the latest figures I've seen. That's a monstrous amount of energy. That's enough energy that if you took all of the energy that's in this amount of space-time and were able to tap it, it would be able to boil off the oceans of the entire planet. So you can see how this technology makes a hydrogen bomb look like a firecracker. That's probably one of the reasons why there's such a tremendous effort to suppress it, because in the wrong hands, obviously, it could be weaponized and be very dangerous. But if used in peaceful ways, of course, it provides you a tremendous amount of power. And that power, when pulling this energy out of the environment, it's my belief that there is a moment in time where it doesn't allow that zero-point energy to interact with the atomic structure of the vehicle. Now, this interaction is what is referred to as the creation of mass. Now, for example, Einstein said you can never travel faster than the speed of light because as you accelerate through space-time, your interaction with the zero-point energy that's embedded in space-time raises your mass. And so it makes it harder and harder for you to go faster and faster, so you can never really reach the speed of light. In fact, he said, if you could, that as you approach the speed of light, that your mass would become near infinite. So imagine then that you're actually using the free energy of zero-point energy. You're tapping that as your propulsive force. You're using it in the environment. So there's a couple things that might happen when you do this. One is that it reduces the mass of your vehicle because you're using the stuff that would otherwise create to its increase. And you're using that to do work. You're using it as a propulsive force. So under that theory, you could actually be able to accelerate up to and beyond the speed of light, because the very energy that would be ordinarily slowing you down by raising your mass is actually what you're using to push you along. Now, in 1994, Miguel Alcubierre, who is a professor at the University of Wales near Cardiff, proposed that you could actually do this without violating general relativity. And what he was suggesting was that you could polarize space-time in such a way that you could cause an expansion of space-time, imagine a supernova, or compress space-time, imagine a black hole. And you could take these two processes and you could polarize space-time in such a way that it would actually take the environment that you're sitting in, that's being sort of generated by your propulsion system, and it would actually use space-time to push you along. So that this little dynamically engineered local space-time is what is moving you along, but your relative position inside that compartment is not changing, so you feel no g-forces. In fact, your gravity and all the sensations you have are sort of pegged to that moment in time and space. But the surrounding space-time is being manipulated in such a way that it's accelerating you along at what he refers to as arbitrarily high speeds, in other words, faster than the speed of light. So anyway, I'm running out of time here, and so I should probably show you a couple of the other things that I was going to talk to. Now, that thing that you can barely see, and this is the original Polaroid photograph taken in 1984. This was taken near Cedarville, California. This is a close-up. This is probably the only photograph in existence of what may have been the first string of vehicles used in what was called Solar Warden. Now, under a loop looking at the original Polaroid, you can actually see a little bit more detail. This was a drawing done by the eyewitness, the fellow who took the photograph. And there were some things about it that I could probably go into, but the thing that's important to remember is that some of the features look remarkably like some of the structure on the so-called alien reproduction vehicle. And in fact, it did seem apparent to him that these wingtips, if you want to call them that, could actually rotate inward so that this thing would actually become more of a triangular shape, which also, of course, would help with issues like storage. Now, this is a little bit more detailed drawing that I did based on what I could see through the loop. Actually looks like there may be some ways in which this area and this area here can be articulated so the thing can kind of fold itself up for storage or for putting it into a hangar. Now, there's a lot of other incidents, eyewitness testimony, pilots that I've spoken to. This particular image refers to a sighting that occurred back in the mid-60s on the way back to Vietnam. That aircraft right there is a B-52, which is a huge aircraft. They said that this vehicle had a translucent illuminated dome that they counted 27 stories in there, and that was kind of how they helped to gauge the size of the thing. But he said that each one of the turbine blades, these are rotating turbine blades around the perimeter here, each one of them was the size of a bypass door on a huge hangar. And so one of the things that was significant about this particular encounter, this is kind of based on an eyewitness, it's just a rough sketch here, but this was taking place at night over the ocean at 1 o'clock in the morning, no clouds, just the moon. And when this aircraft actually, this large disk, which they estimated to be a minimum of 1/4 of a mile in diameter, when this thing departed, as it went out through the blackness in the sky, in its wake was this turbulent, shimmering image of what looked like a blue, daylit sky with clouds. So what seemed apparent to the people, the crew of this B-52, was that when this thing created a wormhole, that there was actually kind of an image dragging that would go along with it, that it would either show you where it was going to or you'd see some of where it had come from. Now, I've personally witnessed that on at least 2 occasions. And very often you find that these types of events are very mystifying and hard to understand because you don't readily understand what it is you're looking at. Now, like I say, I'm running out of time here. This is some more. This is a crash recovery that occurred in May 1989 in East Germany by some of our special forces. It was a vehicle that was utilizing what appeared to be a lot of stealth technology. The canopy on this thing had a lot of the same kind of details that you would see on the stealth fighter. You had the same sort of jagged edges, same sort of features that would help to defeat radar reflection, things of that nature. This is a sort of a mechanical 3-view drawing that was done by my friend and colleague Michael Schratt, who I owe a lot to help me put this presentation together. But what was interesting about this particular vehicle was that it had these spheres that appeared to be made of a white ceramic material, like a superconducting ceramic, like yttrium, barium, copper oxide. When the vehicle crashed, the pilot hit a tree coming over a ridge line and then tried to pull the nose up. He hit tail first, and when he hit tail first, it broke the tail in half, and it released one of these spheres. And that sphere looked pretty much like this. It had a couple of wires coming out of the top. There was sort of like a little circular opening there with sort of a metallic thing in the middle. But it had this beautiful sort of like a pumpkin shape with this sort of a scalloped appearance. And he said that when the thing was bobbing around the field and they were trying to recover this thing, that every once in a while it began to spin and wobble and get a little faster, and then sparks would jump across the two wires that were exposed, and it would slow down. It would start to calm down again. They were given an aluminum utility case to try and capture this thing. They were told not to touch it with their bare hands. So there's two reasons I can think of. One, either they're using cryogenic fluids and it's really, really cold, and they might get a burn, or they might get electrical shock, which seemed pretty apparent. But the thing was floating above the ground. So one of the things we know about superconducting materials is that when they are, and I'm thinking of this in the context of a propulsive system, but if you've ever seen any of the films that they have on the video, on the YouTube or on the internet of superconducting wafers floating above magnets, is they have to be set, as it's referred to, in situ, in order to create that levitating effect. In other words, you have to chill that ceramic material down right at the spacing that you want to establish between the magnets and the object itself. So it'll maintain that attitude. And you can crank it a certain attitude and it'll maintain that attitude, and you can move it around, but it'll always stay in that one reference angle. So I started thinking that if this thing is filled with some kind of cryogenic fluid, and this is some kind of a high-temperature superconducting material or ceramic material on the outside here, you can see that the scalloping may actually create a kind of turbulence pattern on the inside that helps to stir it up. And one of the things we know about superconducting materials is that when they get anywhere near moving magnetic fields, they produce a lot of electricity. And that electricity, unlike normal conductors, which will cause the energy to bleed off, superconductors tend to hold that charge. They tend to hold it for a while. So it occurred to me that if this kind of a thing was going to be used in a propulsive system, that you would want a way of creating a cryogenic situation, an environment inside where you're hovering right above or right below that critical temperature where the superconducting occurs, so that as the aircraft is flying along, it's constantly resetting itself in situ. In other words, at this moment I'm at 15 feet above the ground, but I need to be 20 feet above the ground downrange, so it momentarily drops below a certain temperature or goes above a certain temperature and reachieves that in situ setting of the magnetic field or its relative position in the magnetic field. So this is just some of the things that I've been thinking about in terms of how to make this thing happen. Now, I'm kind of running out of time here, so I'm sorry and I apologize. Just get me started. Anyway, one of the things I like to do in closing is this is the young man who produced the film that you'll probably have a chance to see later on, James Allen. He's passed away now. And this was literally just a month before the film was being released. And he suddenly became very sick, was in the hospital. He died within 2.5 months. And the manner of his illness was so peculiar and so strange, we decided to go have some pathology done. And what we found, it's really hard to see on this chart because it's so small. I wish I could blow it up somehow. But basically, all of these little things here, we see an H next to those levels right there. Those are all radioisotopes like uranium, thorium, beryllium, cadmium, things that you would not find naturally occurring. So it seems apparent to us that he was poisoned using radioisotopes. And so I would like to dedicate I'd like to dedicate this presentation to the memory of my friend James Allen. He's a brilliant young man, had a great potential as a filmmaker ahead of him, and I thank him for the time that he dedicated to documenting what I did. And I'd like to thank you for your time and your attention. Thanks very much.